Este es un capibara, ¿no? O un pacarana. ¿Es un pacarana? Oye, me parece que era un pacarana, ¿no? Tenéis que darme un... Sí. Mis amigos gráficos se vuelven locos cuando ven que hago estas cosas y dicen, no me puedes pedir ayuda. ¿Qué?
¿Qué usas para eso? ¿Es Keynote?
Sí.
Keynote tiene una opción re buena que le decís y te saca lo blanco.
Ah.
Te da cuenta que eso es un círculo y te lo va cerrando.
Ah. Okay. Good morning, everybody, and thanks for attending. I am Domenico Cipriani, and I'm presenting the LiveCoding Package for Pharo. First, a few words about me. I am a professional DJ and music producer. I've been DJing for 20 years, producing music for almost 15. I've been releasing like 150 vinyls, and this is my main occupation. In the last 2 years, I also I've been doing audio software and VST plugins in C++ with the Juice framework, but this is another history for a brand called Soft Computing. And in the same time, I've been developing this live coding package for Pharo, first alone, and then I got some help by the Pharo team in Lille, and I'm really thankful for that. So first of all, we will talk a little bit about live coding in the meaning of on-the-fly programming music. I don't know how many of you have know live coding on-the-fly programming. Okay, so basically, for us that we are using Smalltalk or Pharo, we know what is live coding, but in the terms of an electronic music performance, is an increasingly popular creative practice for audiovisual creation, and the main theme about that is that the composer, performer, programmer has to show the screen to the audience, so there is a kind of transparent relation between the performer and the audience, okay, because it was very typical, it has been typical and is still typical that who is performing with computers is not showing what is happening on his program, so it could be like cheating using some like kind of pre-programmed stuff, or even, you know, like a whole track or a whole set. This is kind of common. So there is an organization that is called TopLap that is taking care of the live coding on the fly programming music aesthetic. There is a manifesto. There are various communities, and they are taking care of kind of purity. And also, the European Union has been funding and promoting live coding through this association like Hangar, ZKM in Karlsruhe, Ludmila in Ljubljana, and Creative Code in Utrecht. So it's something that is growing in popularity. And here we go a little bit with these quotes that I like. The first one is from Abraham Maslow, that is a that was an American psychologist that say if the only tool you have is an hammer, everything looks like a nail. Okay. And the second one is from Alan Kay, and the thing is that the most disastrous thing that you can ever learn is your first programming language. So I was not a programmer at the beginning. I was only making music with the machine mostly, and then I started to make using with this stuff that is called Kima. And Kima is an IDE and a program and a computer language written in Smalltalk, created by Carla Scaletti and Kurt Ebel at Urbana-Champaign. I want to thank them for Kima and for all the things they do for us musicians. That is most probably developed on Object War Smalltalk of 1992. This is probably. And it comes with this DSP that you could see when I was performing that is called Pacarana, or Paca in a smaller version. So I was lucky because when I started programming, I started with this Kima, and Kima is in Smalltalk, and it was very easy for me to understand a lot of computer concepts coming from no computer or no programming background. Okay, so I learned first Smalltalk by Kima, then I want to learn a little bit deeper Smalltalk, and I start to learn Pharo, because Pharo has a lot of good documentation. There is the MOOC, and there is a strong, lively community. So that was facilitating me learning Smalltalk. Then I was learning some JavaScript also. Then at the end I was, by the time, learning some C++ and then actually working with C++. So I think that it could never have been possible, at least for me, to start from C++, at least. And I think there is the same situation is also for a lot of musicians and non-programmer, and so this live coding package was designed with in mind musician that has no programming background, and also for like kids. So it was the idea is to give something easy for the people to learn, and then give the possibility to the people to learn maybe something harder or more difficult. Also, there is a main thing that most of the programming language and that are used for live coding, programming music on the fly, use a functional paradigm. The most popular is Tidal Cycles, that is based on Haskell, and it's basically a front end for Super Collider. We will see a little bit of Super Collider later. And I think, from my perspective at least, that it's kind of hard to learn as a first programming language a functional language, especially if you are not coming from a computer science background. And also a lot of symbols are very cryptic, they are not transparent. So why Pharo? Pharo because it is Smalltalk, and because the manipulation of arrays that are at the core of composing electronic music or composing music in general is extremely powerful. The playground, of course, is the perfect environment for live coding, because everybody's doing live coding for other purposes with that. And because there are not other pure object-oriented language that used at the moment for live coding, it's expressive and it's reflective, so you can look inside that, you can look what is happening, you can define your own new methods, and then you have like no headers, no extra dependence, and no file management, okay? So we already talked about Kima, that is what I'm using, but the live coding package, to use Kima, you have to have this DSP that is called Pacarana, otherwise you cannot use the program. But the live coding package for Pharo is thought not only to be used for Kima, but for any other programming language that has OSC, OpenSoundControl, support. I don't know if anybody of you is familiar with OpenSoundControl. We will see a little bit later. And also thanks to the help of the people of in Lille. Now we have MIDI support, and MIDI support is the main protocol interface used by all synthesizers, done from like 1987, and so you can plug a MIDI interface to your computer, and then you can use the LiveCoding package with your hardware synthesizer. Okay, so basically the LiveCoding package is a front end to write real-time scores for a real-time audio synthesis backend. Okay, so you write the score, you write the music that is being executed, but you have to write your own sounds or to use some other sounds made by somebody else on another program. At the moment, there is no way to create the sounds in the LiveCoding package, but you will see at the end that I'm working on it. So on the other side, the sound generators has to adhere to this syntax. So every kind of note event is composed by an instrument gate, instrument note, instrument duration, and instrument extra 1 and extra 2. It means that, for example, if you're playing a bass on your backend, you have to make bass gate for the event of pressing the note, bass note for having the MIDI note number corresponding to the note on the keyboard. Then the duration, it's how long the note is pressed in seconds, and then extra 1 and extra 2 are used for extra parameters that can be like filter, cutoff, level, volume, whatever. And also, the LiveCoding package is a domain-specific language based on Pharo, where you can quickly and easily create rhythmical patterns, change them, arrange them, and it's especially powerful about creating a manipulating array. At the same time, it would like to be also a kind of ethnomusical quick guide, because if you go inside the method to create the rhythms, okay, so here you can see, for example, if you, I don't know if you can read, but inside, so you create, basically you create a rhythm sending a message to an integer, and you get a number of steps in that rhythm. And now we will see a little bit about that. That the steps can be corresponding to 1 and 0 in an array, because 1 is the note that is playing, 0 is the note that is not playing in a typical step sequencer. And inside every rhythm, you can see where this rhythm is coming from. For example, here in the case of Gau, you say that is it's from the EU people of northern Western Africa. And this was a little bit the idea of making it and putting more comments in it to make it also like a kind of guide. So at the core of the LiveCoding package, there is the performance, that is a subclass of dictionary that contains instances of a sequencer class. I don't know how many of you are familiar with a digital audio workstation. A little bit. So digital audio workstation basically is a, let's call it like, is a software that is playing different audio or MIDI tracks, okay? And this audio or MIDI tracks contains information about the music being played, okay? Then you can loop, you can jump, and then you can mix them. The performance is thought to be like a tracker, so it has information about these sequences, and every sequencer can be connected to an instrument on the audio backend. So the sequencer contains gates that are, when the note is pressed or not, that are arrays, nodes that also are arrays, durations, that is how long the note is pressed, then these extra 1 and extra 2 optional value. And then there is the note index. So every sequencer has his own index, has his own note index, that when it is created, it is 1. And then it's incremented at every step of the performance. And in this way, you can scroll inside the inside the sequencer, and when the note index is arriving at the gate size, it starts from 1 once again. So you have different, the sequencer can have different duration in terms of size of the gates, okay? And everything is modulated in the way that you can also put less notes or less duration or less extra one values, because then the performance class knows that the note index is depending on the gates. Okay, so the performance, we say, is a subclass of dictionary that contains symbols and arrays or sequencers. So what is the thing? The thing is that you create an event and you have something, you need something that is adhering to this syntax that you are giving to the performance to be able to write it. And then we have two messages at the moment. This is the implementation, that is play keyma sequence at a step duration that can be in seconds, or there is a convenient class, there is a convenient method called BPM that you send to a number to get the step duration in 16th at that BPM. So play keyma sequence and play local sequence. The main difference is that when you play local sequence, you are communicating with a local host, so another program that is running to your computer. The Pacarana is another computer, so it has a different address, and it needs a different address. We will go a little bit to the environment itself. Now I'm not using the Pacarana because it would be a little bit slower to connect, and we didn't have so much time. There will be the performance later, like the other day. So now I'm using this program called Chuck, that is another popular program used to sound design and performing music performance and music creation. And basically, what we care is that on the server side, so on this Chuck, we have to create an OpenSoundControl object that is listening on the port that, in the case of the LiveCoding package, 8000 at the moment for default, but of course you can change it. Then, I don't know if you can see, but because it's kind of small, but you can see that I have this kick, snare, clap, tom, and this thing. So it's understanding that he has to receive kick, clap, snare, tom, because I can send them from Pharo. So here in the playground, first thing I create a performance. Okay. Then in this performance, I put, for example, at. So the performance at, we put the name of the instrument we want to play, so snare, and then we put a sequencer. And for example, we send the banda, rumba, bomba, everything, all these messages that you saw on my performance, it creates a sequencer. So if we put it like that, it's putting at that symbol is putting that sequencer, and then we can play P3, play local sequence at 142 BPM for a number of steps. That if we want to not reasoning in steps, we can reasoning in bars, so it can be, for example, 8 bars. Okay. No sound, wow, yeah. What is?
What does the message bars return?
The bars is multiplicating for 16. So one bar is 16 step. Now we have only like in 16th. You cannot do like 30 seconds. Yeah, we don't hear any sound because we have to start the virtual machine in Chuck, and we have to add the thread, that is the thread, and now it should work. downbeats. It's soft, but you can hear it, no? So if then I want like and close hi-hat, I put 16 quavers. I can put a tom, and then so we have all this series of messages that we can send to integers to create kind of known rhythms, okay? Rhythm from around the world, or very classical thing like downbeats, upbeats, quavers, and semi-quavers. Or we have another way to put a sequencer, to create a sequencer in terms of an hexadecimal number. So for example, if we put like 888F, and we send a message pattern to the string, we create a sequencer with this kind of gates. We have to think, we go a little bit back to the presentation so you can see. Okay, so, you know, these downbeats, you can see the representation on a classical step sequencer that is like the step sequencer of this machine from the 80s till now. Every machine, hardware machine that has a sequencer, especially for drums, they use this kind of step sequencer. So when a step is lit, it's playing. What is not lit is not playing. So it's 1 and 0, okay? Black or white. So in binary, it can be like 1000, 1000, 1000, 1000, or it can be in hexadecimal, it can be 8888. So in the LiveCoding talk, the language that is using inside this LiveCoding package, you can create this by sending the message downbeats to 16, or by sending the message pattern to 8888. Okay. Hello. No. What's happening? Just block the computer. Very good. Hello. Okay. Very soft, like I think you can hear the tom, the pattern of the tom. Anyway, we have also a way to take out things from the performance. So it's just mute, and then you have an array of symbols. So we can move the kick, and the snare, and the CH. Okay. And now we will hear all the tom. You can hear the F part, or I can change it on fly. So when you are sending this play local sequence or play schema sequence or play MIDI sequence to a performance, a process is starting, and this process has a high priority, actually a timing priority, so it has priority over everything, almost everything, and it's sending out these OSCC OpenSoundControl messages to the server, and is scrolling inside the sequencers and is sending out the sequencer, the gates in the sequencer according to their length. And you can, basically you can start this process and you can make it very long, like I was making 1 hour long, and with that you can modify the things that are inside the performance in real time. So you can modify this performance in real time. Then, for example, here we have this thing called acid that we put, for example, we can say acid gates, okay, and we say that these are 32 random trigs, okay. So we have also these methods to create like array of random gates. Now you cannot see it, okay, but is 1, 0, 0 random. Also you have like with probability, and you can put a probability like 56, and then we can have like, we can create our nodes. So we can, for example, specify our nodes so in MIDI numbers. So I don't know, put like, and then we can put in the performance the at acid put acid gates, and then we can use this symbol to attach an array of nodes to the gates. You can, there is no an automatic thing at the moment. Is thought to be something. At the moment you have like to hard open an inspector or printing and taking the value.
You use it, or you just play random?
I just play kind of randomly. So I forgot to say one thing. This is intended to, it was born to make live music, okay, so going and perform live, but you can use it to make music in the studio. So it's another way to write music that can be like, of course, different from the traditional way of playing with a keyboard or the traditional way of drawing blocks with a digital audio workstation. I was making a couple of tracks that were released in this way because you can find some interesting way. Of course, once this array is created, it stays like that for all the session. Yes, I think we are running out of time, so I want just to show you another thing before we end. Then if somebody has a question or something, maybe later. So now I told you that it at the moment is like a front end for a back end, and you can like write the score. But I start to do a kind of package that is called Pharo Collider. So Super Collider is another language for real-time audio synthesis, music creation, music composition, that has itself a server-client architecture. So it has its own SC language and its own SC synth, that is the server. So the IDE and Super Collider is a little bit influenced by Smalltalk, so we will find something very familiar. Everything that happened on the server happened by the client, the IDE, sending OSC messages. So we can send the same OSC messages behind these methods, and we can create the synthesizers in Pharo. So we don't need to open the IDE of Super Collider, but we can do it from Pharo. For example, here we can create a new sine wave oscillator. First we have to start Super Collider, of course. Super Collider. We boot its own server, server.local, and then we boot the server. Okay, the server is boot. So now we can go to Pharo, create a new sine oscillator, make it ready for the audio server, put some random walk on a blue scale. No, why? What is that? Ah, yeah. We don't have the performance. And then so with this Pharo Collider package, you will be able, it's on the pipeline, so I have to work about this, and there will be a syntax to create nodes, U generators, they are called in Super Collider, and you can create whatever you want, whatever you oscillator you need, or sampler, or filters, and then you can connect them by Pharo, with Pharo, and at the end you can create all your performance inside, really from Pharo, because now you have to have your sounds pre-compiled or in the Kima or in Super Collider. For example, also we can like allocate some memory, just this, then I finish. We can allocate some memory, so we can load our audio files from Pharo to the Super Collider server. Then we can create a basic sample player. We make it ready for the audio server. We assign it a buffer, and then it should go. Okay. Any question? Okay. Thanks.